Hi everyone. I was going to say good morning, but of course it's not really morning anymore. It's midday. I guess you say good morning in the morning and good afternoon in the afternoon, but no one ever says good midday. Anyway, that's beside the point. This is our latest webcast, our Sunday webcast from the Folly Star Foundation's Yoda Guy movie exhibit here in St. Martin. And today's video is basically for cosplayers or for anyone who likes to build stuff. You know, a lot of the stuff that we talk about here is good for people who build models or just like to play with practical things with their hands. So today we've got Nathan and Jennifer Carter from No Sleep Until Cosplay, and they're going to give detailed information on building VAC form setups and putting electronics and mechanics into costumes and lots of other good stuff. If you're watching this as a recording in the coming days, and you're on YouTube or something like that, and you don't know who the hell I am, I'm Nick Maley. I'm a creature effects designer who contributed to building Yoda and made 60 other movies. I'm an author, I'm an artist, a motivational speaker, and I guess I can say I'm a webcaster too. The Folly Star Foundation is here to encourage young people and old people to be creative and to follow their dreams and not to settle for less just because that's what most people do. And these StarNet webcasts were started to thank our patrons who support us through buying items or through our Patreon site. You can see that there's the Patreon link at the bottom of the page, and you know, without that support, the museum would have closed down months ago. So we do live broadcasts once a month usually. This month has been a little off because of other commitments, but then every Sunday, if we don't do that, then we are doing semi-live broadcasts where I talk to you, you can ask questions of me, and basically we run videos from some of the previous live shows. So please consider being a Patreon supporter, and in the meantime, we're gonna get on with the show. So let's just do that. And here it comes.
There. I'm Nathan with No Sleep Till Cosplay, and Jennifer and I are a duo who do all sorts of builds and props and performances and photography and a little bit of this and a little bit of that. Most of our stuff is self-taught, although we can't take credit for everything. Obviously, the whole cosplay community is collaborative. We like to learn from other people and take what we get from other people's demos and books and things like that and roll with it to build our own stuff. So I'm going to just show off, I think, some of the cool things that we built over the past couple of years. Every project we work on, we try to learn something new, learn new skills, learn new techniques, painting, and collaborate with new people. And that's certainly something that I encourage everyone who's watching to always do. Always be learning new things. So a lot of our builds are big things like Maleficent that you see on the screen now and the Assaultron that I'm talking about a lot. So a lot of these huge projects like this are very intimidating. And I know Nick had a panel a couple of weeks ago on how to do really big builds. So I'm not going to dive into it too much, but the core of it really is to break it down into smaller parts. It's when you look at the Assaultron here, it's not just one big costume. It's all sorts of little pieces. I can't build this whole robot outfit, but I can build this little piece right here. I mean, hey, sure, you can build this little piece right here, or the ball on the end of the end of the antenna. You can build that no problem at all. So, and you can build these individual little plates. So when you're looking at your giant costume, don't be intimidated by a huge build. It's every big build is lots of small pieces all piled on top of each other. Another interesting thing is to get your plan all set up as much in advance as possible, but don't be afraid to deviate from that plan because things happen along the way. But as part of your planning, you want to get as many screenshots as possible or as many sketches. If it's an original character, draw as much as you can of your character. For the Assaultron, I played the game a bunch and creeped around on all the Assaultrons I could find in the game and got as close as I could to take all sorts of detailed screenshots. And one of the people that I learned a whole lot from, Britt from Punish Props, was kind enough to send me a bunch of the in-game models, a bunch of renders of the actual in-game models, which I didn't have the technical capability to do. But I printed just pages and pages of details of what I wanted to do with this, and pages of screenshots for the Assaultron. So have as much reference material as you can, have it handy, have it stuck on the fridge so you look at it every day, have it put on the bulletin board in your workshop so you have all this inspirational stuff that you're looking at every day. And as I mentioned a few minutes ago, don't be afraid to learn new things. Don't look at an outfit and say, well, I can't do that because I don't know how to sew. I didn't know how to sew. And for 2017, my goal was to learn how to sew. So I spent hours and hours in front of a sewing machine, and I hired a friend to help me get started on that. And by DragonCon of 2017, I sewed a whole new outfit for myself and a whole new outfit for Jennifer. And we went as Elrond and Galadriel from Lord of the Rings, and I'm really happy about those. So I don't know how to do something. I don't take that excuse to say I don't know how to do it yet, but I'm going to learn. And that's with everything we have here. Back to the Assaultron, I want to talk about most of the build is made of Sintra PVC foam, and it's my favorite crafting material when it comes to building armor and props. A lot of people like EVA foam, and that's fine. I'm terrible with it, only because I haven't really pursued it that much. So Sintra, it's a sheet material, comes in a sheet like this. Most of what I use is white instead of black, but it's just sheet material. It's PVC, similar to PVC pipe, but as it's made, it's extruded into a foam, so it's not quite as dense and heavy as PVC pipe, but it's still rigid. It's not soft and squishy like EVA foam, and even this 3mm material that I have here is still pretty rigid. It's not as hard as steel or whatever, but it is nice and rigid. And I like this material a lot. You can cut it with hand tools at home. You can shape it easily with a heat gun. You can sand it. You can paint it, in my opinion, more easily than EVA foam. So it's just my material of choice. And when building the Assaultron, I started with this material, but there's also the templates and the templates for how to make the individual pieces. And we're working on a class coming up that's going to be on our YouTube channel and on our social media that's going to get into that a lot more. Plenty of other makers have info on how to build templates, so I'm not going to get into that too deep right now. But I made a ton of templates out of duct tape and cardboard and all sorts of stuff, and made these templates when I was working on this. So this is the template that I made for the inner thigh piece of the Assaultron over here. Once I was done with that, I've got this. I trace it out. I cut out the Sintra with either a sharp knife or the thicker material. I'll use a jigsaw, hand shape it with a heat gun, and then paint it. So most of it is built from that. When people see what did you build the Assaultron out of, I like this rigid PVC foam. It goes by the brand name Sintra or Celtec or Comatex. Not to poo-poo on EVA foam. A lot of people love it, and that's great. And there's people like SKS Props that are bringing out the high density foam that's really, really good, and I really need to learn how to use that. But Sintra is my material of choice. A lot of the other stuff in the Assaultron is styrene. Now, there's a lot of stuff a lot of these pieces that are really hard to hand form. I couldn't make a template to make a dome shape. These shoulder domes, these would be really hard to hand shape. Or these ear caps. This guy here, this ear cap would be really difficult to hand form out of a sheet material like EVA foam or Sintra. So one of the cool things that if you're a medium to advanced maker and you don't have a vacuum form machine, then you want to check out Punish Props, who has a great tutorial on making a vacuum form machine. And that was one of the key things that helped me finish the Assaultron, was this vacuum forming machine. Vacuum form parts weigh almost nothing. They're really sturdy depending on what you use. And you can vacuum form all sorts of material. You can do styrene, which is thin plastic. It's used in a ton of model making and prop building and things like that. You can vacuum form clear materials such as PETG or polycarbonate. And that's these claws over here that you see that are lit up from inside. These are vacuum formed polycarbonate. You can vacuum form thin craft foam even. And I would not recommend vacuum forming PVC, because PVC, Sintra, if you get it too hot, it's going to release toxic gases, and we don't want that. It's going to turn into chlorine gas. So a lot of the other materials are much safer to use. I would still recommend doing it outside. Just for the purposes of this demo, I'm going to show you using it inside, so don't tell anybody that I'm actually running the vacuum former here inside. But if you go check out the Punish Props YouTube channel and search for their vacuum forming, they will show how to make this one. And I'm going to demonstrate it on one of the things that I used it for on the Assaultron over here. This cost me about $40 to build this vacuum former, and $10 of that was buying an old toaster oven on Craigslist. About 20 of that was getting these angle aluminum material here from the hardware store, and other, little screws and angle brackets and things like that. So if you have a well-stocked shop at home already, you can probably build a vacuum former for close to nothing if you already have a shop vac. So all it is the toaster oven, and I made this frame out of the angle aluminum to fit. I made it as big as I could to still fit inside the toaster oven. I've got a sheet of styrene here. Going off on a tangent, I love to use junk and recycled materials and found objects. All of my styrene vacuum form pieces here are old Walmart signs, so you can still see the Walmart logo on here. This is like 1.5 millimeter or 2 millimeter styrene. So scavenged from a buddy who works at Walmart that was going to throw all this styrene in the trash, and I said, no, don't throw it away. I can use it for all sorts of stuff. The Assaultron faceplates are made from old retail signs from Circle K hot dog sign. So reuse and recycle your old scavenged found things whenever you can, to save you some money on your bill and to just be safer for old Mother Earth than just throwing plastic in the trash. The last thing I built for the vacuum former was this box here. This is just scrap wood and a pegboard surface. You can use a metal grid for the surface as well, but I made the frame as big as I could possibly fit in the toaster oven, and then I made the box the right size to fit the frame. So what I've got here, I've got my frame, my styrene, and I'm just going to clip it together. And I'm not going into too much detail on this because Punish Props has a tutorial that's way more in-depth than what I have time for here. Getting this put together. And this is only going to take about 2 minutes in the toaster oven. So I will show off some of the other vacuum form pieces while this is heating up. And you also need some handy dandy heat resistant gloves. So have some of those on hand if you don't want to burn yourself. So I'm going to put that in the toaster oven, put it on bake, which, toast, pardon me. Toast, which turns on the top and bottom heating elements at the same time. That's going to take maybe 3 minutes. I've got my shop vac over here that's ready to go. So I've got a hole drilled in my box here. Shop vac is going to go in there. Meanwhile, my material is heating up. And a quick little chat on what you can vacuum form. You can vacuum form just about anything that doesn't have steep, rigid walls and doesn't have any undercuts to go underneath it. So I couldn't vacuum form, say, this ball that's on this mask here, because when the vacuum material goes underneath it, I'm never going to get that ball back out without cutting it apart. But this, I'm going to use this IKEA bowl just as a quick and easy demonstration. This will be perfect because it's nice and smooth, doesn't have any undercuts, so the vacuum material is not going to go under the ball, and it's right there. So we're going to vacuum form over that. This piece here that I pulled off the Assaultron just a minute ago, this little guy was vacuum formed. A lot of the domes, the ear caps were vacuum formed. The claws were vacuum formed. So if you're looking for a new project, build your homemade vacuum former, because that was one of the key things for the Assaultron. All right, I'm going to look at my material in here. It is starting to get warm in there, but I'm just going to give it a minute. You can use a thermometer to tell if your material is warm. I like to just reach in with my gloved hands and poke it and look at it. It's when it starts to kind of sag a little bit, then you'll know it's getting really close to being ready to pull your vacuum. It is taking a little bit to heat up, but it's coming along there. For your bug that you're vacuum forming over, you can use found objects around the house like this bowl. I used a glass lighting fixture for doing the shoulder domes, but I tried to do them with this bowl and a couple of little bowls. Couldn't quite get the right shape, so I just used a glass lighting fixture dome, and those were just about perfect for these shoulder domes. Or you can make stuff yourself out of wood, out of resin, out of whatever junk you have around. I would not recommend using a 3D print for a vacuum form buck, because the heated material that you're vacuum forming is going to be hot enough that it's going to deform your 3D printed piece. So you might get 1 or 2 pulls out of it, but in the long term, I wouldn't recommend using a 3D print for your vacuum form buck. We're starting to get there. I don't have a close-up camera here, but plastic is starting to get nice and soft in there. And all right, here we go. I'm going to turn on the vacuum so that it is ready to pull back, and that is ready to come out and be vacuumed. So here we go. All right, well, all right, I messed it up, which is fine. Styrene is cheap, but my box isn't quite square and my frame isn't quite square, and it only really fits in one direction. So my pole didn't come out perfect, but you can still kind of see that I got pretty close there. What used to be that flat plastic is now a vacuum form piece, and this is still, even though I kind of screwed it up, it's still probably salvageable if I only needed the top little bit of the dome. So that was entirely my bad, putting the frame onto the box in the wrong position. So maybe I'll do another one, but I've got some other things to talk about as well. But anyway, you can make your buck out of wood for the claws on this Assaultron hand. These I vacuum formed. This dome here I vacuum formed, I think, out of a slightly different shaped bowl. So all sorts of shape that would be hard to form by hand. Build a vacuum former and make them out of that. Next thing I want to talk about, we'll pretend this worked well, and I've got plenty of other videos showing this off on our Facebook page. And if we have time later on, I'll try another pull. But I don't want to use up all my time messing with the vacuum former because I have lots more to talk about. Happy little accidents, I guess. Is that what we're saying? And ding, we're done. Another thing I want to talk about is painting. One of the reasons I like styrene and Sintra and other things over EVA foam is it's so easy to paint. You know, if you're familiar with making things out of the soft foam, you have to seal it and prime it, heat seal it or plastic dip it or vinyl coat it or whatever before it's ready to really take your paint. But with the Sintra, as soon as your piece is shaped and refined, it's pretty much ready to paint. I like to do a coat of primer. And the primer that I usually prefer is Rust-Oleum filler primer. I coat all my pieces with Rust-Oleum filler primer, and you can see this entire Assaultron laid out. That's right after the first coat of filler primer. Actually, that was probably a couple of coats of filler primer and some sanding. I usually don't sand a whole lot if I'm working on a piece that's going to be matte. If I want a piece to be super glossy, then yeah, I'll sand it up to 400 grit or 800 grit if I'm going for a glossy coat. But if you're going for a matte coat like the Assaultron here, you don't have to do a whole lot of sanding on your surface, especially if it's going to be weathered like this. If your paint isn't perfect, it's been in the wasteland for 1,000 years, so it's fine if it's a little beat up. If you want a glossy finish, then you can go ahead and sand it, wet sand it, 200, 400, 800, more or less. I'm not going to get too deep into sanding and to getting a perfect paint finish here. But you can certainly sand this filler primer. Even the one that doesn't specifically say sandable filler primer, you can use the one that just says filler primer. And it's, as far as I can tell, they're almost identical. Then you can use, I'm a huge fan of rattle can spray paints. This is almost all rattle can paint because it's easy, it's accessible, and I don't own an airbrush yet. And hand painting with just inexpensive acrylics and just hand brushes. But all this is rattle can spray paint. It's a base of the Rust-Oleum filler primer, then an undercoat of a metallic silver, and then a top coat of this camo military green. There's a couple other things that you can do with this though, and the Assaultron's been out of the wasteland for a long time, and the paint's getting pretty chipped and beat up. And I'm going to show you a cool technique on that. If you have your piece that you've primed, and in this case I've only done primer, I haven't done the metallic coat, but on the Assaultron I did the primer, then the metallic coat, and then the top color coat. A really cool technique you can do is a paint masking technique using liquid latex. You can also use toothpaste. You can use, I did some stuff using hot dog mustard, anything that's going to get in the way of your next coat of paint. And you'll use liquid latex. I prefer liquid latex. It seems to come off the easiest out of all the things that I've tried. So liquid latex and a Q-tip or a Q-tip or a torn piece of paper towel or something like that. We're going to get just a little bit of liquid latex on here, and we're just going to where's the paint beaten up on this piece. So I'm going to think on the Assaultron, where's the paint going to get beat up, and on the pieces that rub the most, along the edges there, along the edges and corners of this piece, I wanted the paint to be chipped off there. So I'm going to take this little bit of liquid latex and just go gently along the edge and maybe make some little splatters there. It doesn't take a whole lot, so don't overdo it with the liquid latex. A few little splatters, maybe a little more on the edge, but I'm not going to overdo it here. I'm going to let this dry, and once that's dry, I'm going to put the top coat on of whatever my color code is going to be. And this technique works really well for whatever it is you're building that you want it to be weathered. If you're building a Mando that's going to have a beat up paint job, or your Boba Fett, or your wasteland armor, or anything that's been out in the wasteland or out in the galaxy for a little while. And once this is dry and you apply your top coat, in this case I did red. So now we have the primer and the base coat, then the liquid latex, and then the top coat. That liquid latex is going to rub right off. So let's see if I can get this. You can see that liquid latex coming off of there to reveal the base coat. So that's going to look like your real paint damage there, because that actually is real paint damage. And I prefer this technique much more than doing your base color coat and then getting a paintbrush full of silver and trying to dab your silver on top of your color coat to try to make it look like paint damage. That works, but that's kind of the entry tier battle damage. Using a paint mask like liquid latex or a genuine masking agent or mustard or whatever is going to give you a much more believable paint layered effect when you rub off that top coat to reveal what was originally underneath, instead of trying to paint the silver on top of it. And I kind of went overboard on this one. I should have planned my layout of my battle damage a little more, but this is just a little test piece to show you how it worked. So that's one of my favorite painting techniques that was something that I had not done before I did the Assaultron. So you can see the paint damage along the thighs here, along the shoulders, a little bit on the face, along the edges. So painting technique, super easy to do. So if you're making something that's going to be battle damaged, use this paint masking effect with liquid Apex or toothpaste or anything like that. You can also use wet, not really wet, but slightly damp rock salt, which will give like a pitted effect, like sandblasted or shot with a shotgun or something like that. Yeah, thank you. Another super important concept is when you're building a full suit of armor like this, when you're building a robot that you're going to wear, when you're building something that like this, is don't just go building the thing without figuring out how you're actually going to wear it. So as I'm in my first steps along the way of building the Assaultron thing, and how am I going to wear it? How are the pieces going to go together? What individual pieces need to connect and how? This is almost entirely put together with straps, webbing, snaps, parachute buckles. Those are the things that I used on almost all this stuff. So I'm going to disassemble a little bit of this here to show you, and magnets. I'll show you some magnets as well. But I'm going to show you some of the things that I did to get this put together. So I'm going to pull off the arms here. You can see the shoulder armor, the chest and back armor have like suspender straps that go over the tops of my shoulders, and that supports most of the weight. That supports all of the weight of the chest, of the back plate, and of the arms. Everything in the upper half is supported by those suspender straps that go across the top here. And the individual arm components, same way. I've got one long strap with a snap. See the single, I've got a single snap here at the top of this arm strap. And this arm strap is going to run down from this strap down through the shoulder belt. Can you give me an overhead cam? It snaps on the top of the suspender down through the shoulder belt and down into the bicep. Then the bicep at the bottom has another strap and a little bit of elastic that goes down into the forearm. So everything is snaps and straps. I love a single snap like this because this gives me a point of rotation. It's a sturdy connection. It's not going to pull loose, but it's also going to rotate freely once it's snapped together. These snaps are Tandy from Tandy Leather, line 20 for kind of smaller ones, like this guy here, and line 24 for the slightly bigger snaps. And almost everything in here is Tandy line 20 and line 24 snaps. And you can see, Jennifer, can you have the overhead cam again? So you can see I've got where I don't need that pivot on the back plate. The back plate doesn't need to pivot. So I've got two snaps there, and on the front, I've got two snaps there. And those, these snaps on the chest and back are, I don't need them to pivot, but I do need additional strength. So if one of them pops loose, I don't collapse into a heap on the ground where all my armor falls apart. So two snaps there. My side straps here are a single pivot and a parachute buckle. So these go around my rib cage and then buckle into place, but they have a little bit of motion there with the single snap. So get you some cotton webbing or some nylon webbing, a little bit of elastic if you can. I've got elastic stitched to the cotton webbing, so I have a little bit of flex there, so it fits snugly, but also is a little bit of give. So that's certainly a way to do that. And on the other side, you see I've just set the snap into a little bit of poly webbing and just used super glue to glue that right to the central armor. So this is glued securely on, and the strap is ready to snap on there. And here's these points here are where I didn't plan very well and put the initial connection points for the straps, the side straps, in the wrong place. So I just put on a different connection point there and was able to move the strap to a better place. So that's your strapping. Highly recommend doing those kind of things, and parachute buckles like these guys here that go around my rib cage and snap together. Magnets are also my other favorite thing that I didn't use before the Assaultron, and where I can get away with it, the pieces like this antenna on the back, I've got just a single big magnet here and a steel washer on the inside of this antenna, and it just snaps onto the back there. And one of the cool things about a magnet attachment is if this gets bumped or knocked around or whatever, it's not going to break. If you have something that's firmly screwed in, and then if this gets knocked off, it's just going to break, or it's going to injure the person that bumped into it. Whereas with this one, it's going to fall off onto the floor, which is way better than poking somebody's eye out or breaking outright. I'll come back to this in a few minutes, but let's talk about some electronic stuff. Again, the Assaultron is the first time I ever did any electronics or soldering or anything like that. And let me tell you, this is one of my favorite things about the Assaultron is the stuff that lights up and the voice box that's in it. I'm going to start out with showing the claws here. And I'm not going to go super deep into the electronics. There's a ton of other resources out there that are going to do a better job of explaining than I can here in just a 10-minute block that I have to talk about the lighting here. I would look at, there's a book on Intro to Cosplay Lighting by COSPLAY, another great cosplayer and builder to follow. She shares a ton of great information on her website, but as she says, buy her books. She's got that Intro to Cosplay Lighting book that is just fantastic, and it was one of the references that I used. So basic lighting, don't be afraid to experiment with stuff. The components are really inexpensive. A single LED is pennies. If you buy a bag of 100 for $10 or whatever. So if you mess up and burn up some LEDs while you're experimenting, that's fine. You have a bag of 100 of them, and you can afford to lose one or two when you mess up. And believe me, I messed up some things. I burnt some switches out. I burnt up some IC chips while I was working on this. And the individual components aren't really that expensive. I would very strongly recommend picking up a breadboard. And the breadboard is just this little component, test component here. And this allows you to plug in your pieces all together to test your connections and to set up your circuit without soldering things together. So once you're sure you have everything working as expected, then you solder things together. So you don't have to worry about you twisting wires or crimping and clamping and everything. You just plug your stuff into the little holes on the breadboard in the right way. I'm not going to go into super deep detail on how to use the breadboard, but I'm going to plug in my power source here, and it's going to power up the rails along the side, and then each horizontal row of pins is connected. So instead of twisting wires together, I just put a wire into one hole and then put a wire into another hole next to it, and those will make an electrical connection. So let's say I want to light up a single LED, which is the most basic electronic thing you can do. And I've got some LEDs here. I bought a huge assortment from Edgelec brand. You can kind of see on the packaging here. Jennifer, you switch to the side cam. You can kind of see this Edgelec brand. I bought a giant assortment of them. It was like 20 each of 10 different colors for just a few bucks on Amazon. And those came with some resistors as well. I also bought a resistor assortment pack and the breadboard with assorted components and things like that. So I want to make, here we go. I've got a yellow LED. I look on the packaging. This yellow LED needs 2 volts. I like to use USB power banks for just about everything. USB power banks are ubiquitous. They're everywhere. Everybody has one to charge up their phone. If you lose it or it breaks, you can go to Target and buy another one. They come in all sorts of shapes and sizes and capacities. I've got my Fallout Power Core bank here. I've got this guy that I got from Target that was only a few bucks. I've got this that I can't remember if I bought this or found it or whatever. But these power banks are plenty to drive lights in your cosplay for the entire day of the con. And it'll tell you how many milliamp hours are on each one. Bigger is maybe better, but you don't need a huge power bank just to run some LEDs in your costume. These are always going to be 5 volts output. But my LEDs want these, if I look on the package, it says they want a 2-volt output. So how do I get from the 5-volt USB power bank to the 2 volts that the LED wants? Well, if I just plug in the 5-volt source to the 2-volt LED, it's gonna, maybe it'll last a minute, maybe it'll burn up right away. It's not gonna last the life of the costume. We certainly want to step down that voltage to make the LED light up and not immediately burn out. So you've got a resistor, and there are calculators online. I like to use ledcalc.com, which is, so I don't have to do the math. Sometimes I like to do the math, but not in this case. But if I calculate, if I go to ledcalc.com and I punch in that I have a 5-volt source and a 2-volt LED that needs, it says on the package here, it's going to be 20 milliamps. It's going to tell me the size of the resistor that I need. And that's going to be about, I think it's about 200 ohms is what I need. So I have 220 ohm resistors here. They're close enough. Most of the time, if your resistor is close enough, that's going to be fine. So from my 5-volt USB power source, I'm not going to plug this in quite yet. I've got 5 volts coming in. This resistor, based on the calculations from ledcalc.com, is going to bring it down to the 2 volts that I need. I'm going to plug into the hot side of the power, the positive side of the breadboard. I'm going to arbitrarily pick a hole over here. And your resistors are not directional. You can have either side touching the positive and either side touching the negative. So I've got this 5 volts. The resistor is going to step it down to the 2 volts. So now on my LED, you can see the LED has a long leg and a short leg. And the longer leg is always going to be the positive side. If you plug it in backwards, it's just not going to light up. You're not going to burn it out or anything. It's just not going to work. But I'm going to make sure to plug in the positive side to the side that's going to the resistor, which is downstream of the positive, and on the breadboard, the negative there. And that's my circuit. That's all I need to make this LED light up. I'm watching it work or not work. Oh, there we go. Perfect. Now we're ready to put this LED into my cosplay. Or not. Maybe I want 2 LEDs. I can run them in parallel, or I can run them in series. There's a ton of great circuit builders out there to help you design circuits, but don't be afraid of messing with this stuff and experimenting with it and watching some tutorials and adding some LEDs and lights to your costumes. You can see the cool stuff that I did with the Assaultron, and this was the first electronics project that I ever did, and it's really not that hard. So don't be afraid to dive into it. Certainly get a breadboard. I think my battery's maybe not full there. Get you some cheapo LEDs from Amazon. I like the Edgelec brand. There's a ton of other brands out there, or from AliExpress if you don't mind waiting forever. I can put 2 of them right next to each other, and now I have 2 LEDs that are both using that 2 volts. I've got some other things. Okay, so I've got a blue LED here. I know this blue LED needs 3 volts. Is it going to work with the same resistor? To get to the 3 volts that it wants, I would probably need a smaller capacity resistor to let more voltage through to get to the LED. But what happens if I mess up and put a resistor that's too big, so it's not quite getting the full 3 volts that it wants? It's only getting 2 volts. Guess what? It's going to work. A lot of these voltage things, unless you give it too much voltage, a lot of times you can underpower your LED and it's still going to look just fine. And this one is flickering because here's a cool thing. These LEDs, again, Edgelec brand that I got from Amazon, already have the flicker effect built into the LED, which is one of my favorite things that I found on these. So the Assaultron claw here already kind of has that electrical short out flicker effect. That's all built into the LEDs. I didn't have to program these or do anything special. Just send them the 3 volts that they want, and they're gonna have that flicker effect. So there's lots of cool resources out there that the LED by itself will flicker on and off, or turn on or off, or pulse at a certain frequency. So the long and short of it is, this is all it takes, is this and maybe some wire and solder and heat shrink. I'm not going to get into soldering right now because that's out of the scope of this little demo. But there's tons of other great tutorials on soldering out there as well. I think the Kamui Cosplay book has a good tutorial on soldering. And your LEDs are almost always going to need between 2 and 3 volts. Your USB power supplies are always going to give slightly more than that, so you can step it down with a resistor. And if I were to wear this around a con, well, this claw, which is essentially the same USB power supply, this claw will last all day today and all day tomorrow. I'm never going to have to swap out this USB power source. Some more advanced things. These little 5mm LEDs are pretty ubiquitous and cheap, but sometimes you need something that's a little more than that, like the Assaultron eye there, which I wanted something to be pretty bright. The eye is the Assaultron's main weapon in the game, and it's supposed to be pretty bright and scary. So I found a really bright LED from, I think it was ledsupply.com, and that needed a little bit more math associated with it. And I also wanted to be able to run the Assaultron eye at different power levels, which I kind of realized after the fact. I probably should run it at different power levels, because this guy, if I run it at the normal voltage that it wants, is ridiculously bright. And it's just too bright to wear around a con. It's even too bright for most photos. So, okay, I can make it a little more dim, a little less bright, just by running it at a lower voltage than what it wants. So what I did, I'm going to pull up the helmet here, and one of the other cool things that I did, I challenged myself to make the mask completely separate from the rest of the headpiece for this build. So what I did is I ran a bunch of different calculations and ultimately came up with some switches. Jennifer, let's have the overhead cam. I've got some switches here that route my battery power through different resistors depending on how bright I want this laser to be. So if I flip these switches, and I can do that while I'm wearing the mask, I just reach up and flip it next to my flip the switch next to my cheek. If I flip these switches, it'll run through a resistor that's more or less ohms to have a brighter or less bright LED or off. So you can see I have a few different power levels there depending on which switch I have turned on. So certainly if I'm walking around a con, you don't want this looking in your face if you're walking around a con floor, especially if it's dark or kind of dark inside and I'm the brightest thing in the room. That's very frustrating. So the switches will route the power through different resistors. So a little bit of extra math, a little bit of extra challenge for yourself. Yes. Yeah, so the jacket is the next thing that I wanted to talk about there. After doing all this electronics, I got pretty excited about my ability to do things like that. So this jacket is my first Arduino programmable microcontroller project. And now that I've done this, I've got a whole new world of cool things that I can do. But just the animated light effect on this jacket is one of the favorite things that I've built so far this year. This is one of our most recent projects. Now this uses the Adafruit Flora, which is designed for wearable things. You don't have to use the Adafruit Flora. You can use any Arduino. You could probably use a Raspberry Pi, but that's kind of overkill for it. And I found there's no better time to learn this stuff than now. There's so many resources out there, so many other people doing it. There's Facebook pages where people get together and talk about it. There's Reddit pages, there's books, there's online forums. So I said, here's what I want to do. How am I going to make this work? There is some code involved in the light, but I didn't write that code from scratch. This is the code to make this flicker is code that somebody else wrote that I just put on the Flora, and it pretty much worked almost out of the box. So it does help if you have a little bit of a logical puzzle solving mind. It helps a little more if you have some programming background, but even if you don't, there are pre-written codes out there to do things like a flame effect or a light that pops back and forth or lights that pulse on and off at whatever rate you want. So yeah, let's take a look at this. And whenever you're doing a more complex circuit, this one I made it more complex than it needed to be because this used some of the LEDs that I had, but not all of them. And I had some more left over that I wanted to use on a different project. So I physically drew on a piece of paper how I wanted the lights to be laid out. So I drew, here's the flora, here's my battery that's going to power it, here's a push button switch to turn it on and off. On the front of the jacket, you can see when I pull it off the mannequin, there's the Harris blaster that has a little light up blaster shot that comes out of it, and then I've got the flames that are here on the back. So I drew how am I gonna route these wires and the different LED strips, and so much of this stuff is explained on Adafruit's tutorials. So I'm not going to get I keep saying I'm not going to get super deep into it, but that's how I keep what this is, more just an overview and our demo. Tons of info on Adafruit's site, and here you can see the front of the jacket. Right now I got it plugged in because I didn't have yet another battery to power it up. But you can see on the front of the jacket, it's got the let's go to the overhead cam for the front here. Line up these. It's not completely finished, but you can see the blaster here with the blaster shot that comes out of the tip of Hera's blaster. So inside, well, let's talk about the electronics first. Again, this is just powered by USB, and I've got it plugged into a USB wall port for now, just because I didn't have a spare battery that I remember to charge. And the good old Adafruit Flora that's here running the fire and the blaster at the same time. Just a little round programmable microcontroller, suitable for wearable projects. You don't have to use a Flora. Lots of other Arduino components will work well for this, but this is running the code to make the blaster and the code to make the fire. And now the lights themselves, I've got them kind of stitched together. These are just programmable LED strips. And the code that's running on that microcontroller is individually animating each of these lights. And that's code that I downloaded from somebody else that does this flame effect. If you're a good programmer, or once you get really into it, you can certainly write the code yourself. And I did have to tweak it a little bit to make it run the fire and the blaster at the same time. But these lights are shining through a piece of upholstery foam and through a piece of clear orange vinyl. And this upholstery foam diffuses it. So because you don't want the fire to look like a bunch of individual LEDs, you want it to look like kind of a diffuse flame effect. So those strips of LEDs, and I've got it angled so that it lines up with the design on the back. And there we go, Jennifer's light up jacket with the Spectre logo. I'm really excited about this. I've got one that we're working on for Kate and Jairus as well. That's halfway done. But this was my first Arduino project. Again, I got to emphasize there's no better time than now to learn a new skill or a new trick or a new tool to use. 4 months ago, I didn't know how to do any of this. So if I can learn it, you can learn it too. Another thing that I want to show off, in addition to just lights, there's other cool things that you can do with your batteries and electronics. And if you're local to Tampa or Florida, we have an annual convention in December called Holiday Matsuri, and you don't have to, but a lot of people choose to make a holiday themed version of whatever their favorite costume or cosplay is. And it's one of the most fun cons I've ever been to. Everybody has ridiculous Christmas or holiday themed takes on their own costumes or their own fandoms or whatever. So I took the Assaultron, which is completely modular, and I made a bunch of silly Christmas accessories to go with it. And my favorite is this holiday buzzsaw, which is nice and dangerous here. This is nice soft EVA foam. This is one of the only things that I've used the soft EVA foam for, is my saw blades here. And my hand goes in there. And when I squeeze the trigger inside here, I've got my spinning and light up saw blade with the silly ornament there. So for motors, I don't want to design. I'm not yet to the point where I'm going to design new motorized things from scratch. But what I am going to do is use pieces of some other thing that already exists. So what I did for this, how can I make a motor that doesn't spin super fast? So I don't want it to spin as fast as like a drill. I want it to spin a little slower. So what I found was a low RPM cordless driver from Harbor Freight. I think it cost me like $8. Everything on here is junk that I already had around the house except for this cordless driver. And I hacked apart the cordless driver, and the handle and the battery are inside the handle here, and the motor itself is over here on the side. I just took the motor out of the drill housing and put it inside this. This is actually an old pill bottle, I think. So you can see kind of in there. I don't want to take it too much apart, but there's the motors inside there, and still has the original drill housing. And it's shoved down inside this pill bottle, and I hacked together out of scraps a little lid to go on top of it. So this is just the cordless drill motor, and inside here is the cordless drill handle and battery. That it's just the original thing hacked into two. And this is ridiculously fun to wear the holiday version of the Assaultron. So if you want something that spins or moves, there are certainly things out there that you can get, servo motors and stepper motors and all sorts of things like that. Definitely dig into those if you like, or just hack together something that you already have, a piece of, an old toy that spins that's sitting around the house that nobody uses anymore, or an $8 cordless screwdriver from Harbor Freight to make your spinning saw blade. Okay. Other thing that I want to show you for motorized things, not everything has to spin. You can use a solenoid or a linear actuator to make things move in a certain direction. And I'm going to show you the guts of Jennifer's Maleficent wings. So she's going to show you a little video here while I grab the wing. And this is from this past Dragon Con. Maybe she's going to show a video, or maybe or some photos. I don't know. Well, while she's looking at those, I'm going to grab this this wing, and we'll look at it on the inside here. And I'm gonna preface this by saying this wing is not our design. Again, we'll collaborate with other people who have already done something similar to what you want. So this design is by another cosplayer and maker called Crooked Feather. And Crooked Feather, she makes, she designs and builds, and sometimes has commission slots open for things like this. Jennifer, giant wings like this have been on Jennifer's wish list for years, and for 2019, we finally bit the bullet and dove into these giant wings. And they open and close on command. And we plug them in over here. And these are driven by a RC car battery and a linear actuator. So Jennifer's got the remote here. And normally these are strapped to a corset, so the weight of these wings are all supported by the corset that's sitting on her hips. And she's got a little RF remote control that goes to this RF receiver that's here in this receiver box. The power from this RC car battery that supplies up 12 volts-ish, and this 12 volt linear actuator that's going to push this mechanism and open up the wings. So Jennifer is going to hit this, hit the remote. Maybe the battery's dead. Well, it could be this battery over here is also. We should have checked it. But when Jennifer hits that button normally, this linear actuator is going to push out here, and these wings completely open to the giant 16-foot wingspan. So in addition to just rotational motors, there's tons of other things that you can do. These linear actuators come in all sorts of sizes. Oh, Jennifer, you might be too far away also. Maybe give it a toss. Here, let's see if I can catch it. Almost got off the hand. All right, let's see if she was just too far away for the. Nope, I think our wings battery is maybe didn't get her charged. Well, we'll just pretend. So these open up. They're bolted to the corset here. You can see these 6 holes here that bolted to the corset, so all the weight sits on her hips. So there's almost no weight on her shoulders. And these open up to 16 feet wide and then close back down to only about 3 feet wide. So go check out Crooked Feather, her Facebook page, her YouTube tutorials. She has a ton of free YouTube tutorials. She sells plans for these if you want to build your own. She sells components or entire kits, although I think the kits are probably on a pretty big backlog of what she wants, of what she's available to make. But this linear actuator is the key component to having these things that open up and close in, and it's strong enough to open these giant 16-foot wings. And the last fun electronics thing that I wanted to show you, probably my favorite part of the Assaultron. I'm taking everything over here. My favorite part of the Assaultron, I'm going to give you a little preview of what's inside here. Power up my battery. Power up here. And I've got this little RF remote that I palm inside the claw gauntlets.
Weapons hot. Scanners detecting sentient life.
Yeah, that's okay.
Alert level elevated.
I've got an audio chip in here and speakers in the chest plate, and this will play a bunch of different voice lines from the game.
Don't worry. I only test the weapons on customers I don't like. Feel free to browse. Sensor alert. Anomaly detected.
So absolutely one of my favorite things that I've ever made is this voice box that's inside here. So I'm going to give you a quick rundown of what this is. The core of this is the Adafruit brand. I'm going back to Adafruit, which has not just the stuff on the school light up jacket, but just tons of other fun electrical components and other programmable things. One of the things that they sell is a programmable voice chip that you don't, I say programmable, but honestly, the programming consists of naming the files. There's no code to write. There's nothing like that. You just name the files and using a certain standard to tell it which button is going to play which sound or which set of random sounds. So the Adafruit brand audio effects board is one of my favorite things that I've found. And this is before I knew how to do any of the programming that went with this. This was a couple years before that. So inside this box, I've got the audio effects board and the RF receiver for this RF remote. And on the other side here, I've got a little 12-volt amp. And then to power it, I've got this Milwaukee drill battery with this power sleeve that'll put out both 12 volts and 5 volts out of, yet again, another USB 5-volt power source. So the 5-volt powers the electronics that are inside this box, that Adafruit audio effects board. The 12-volt powers the amp over here. And I've got just barely enough space that when my padding is in place there, it is nice and comfortable to wear, and none of this stuff gouges me in the chest or anything like that. And I've got the remote that is clipped to my sleeve inside the claw. So anytime I want to sound menacing,
Assessing threat. Hostile is clear. Standing down.
just mash that button. So it's certainly one of my favorite things that I've ever built. And this took, it did take some trial and error, but so satisfying to learn a new skill, learning the soldering that it took to put it together, and having it work as expected once it was all assembled. But no programming. I didn't have to write any code, no Python or Java or anything, whatever code you like the kids are using these days. It was just naming the files. Once I got the files out of the game files, I just named the sound files to the format that the audio effects chip wanted. So that's oh yeah, how are we doing on time? Well, oh, that's a great question. So next up on my list is a wearable IG-11. Everybody loves IG-11 from The Mandalorian, and I know it's not going to be perfectly screen accurate because I'm not 7.5 feet tall, and the proportions won't be perfectly accurate because my arms, even though I'm a skinny dude, my arms are still a little bit too thick for that. So the proportions are going to be a little bit off. I don't care. I'm still going to have a blast building it and wearing it. So I'm going to take all the stuff that I've learned in all these projects and the programmable stuff that I've learned from this jacket and the lights and the 3D printing that Cynthia was talking about a little while ago. Yeah, and Jennifer gets to make a plushie baby Yoda for me to carry around and protect. So Nurse Droid IG-11 is next on the chopping block for me, as well as a non-canon original character fairy to accompany her Maleficent. Because I get to wear her hand-me-down wings that don't open and close, but are still, yeah, the wings that she's showing there, the brown wings, she handed down to me to wear for a fairy with horns and claws, I guess. So that's next on my list. So yeah, look out for IG-11 coming soon. I had hoped originally to have it done by DragonCon, but I don't think we're hitting DragonCon this year. So probably by springtime. I'm kind of taking it easy on that and setting up a lot of things. So that one's going to be a mix of Sintra and 3D printing and probably some resin casting. have to learn the new technique. Then really it's the next thing that I want to learn is going to be more mechanical things that I don't have to hack apart a cordless drill to make things work. For instance, for IG11, I want to take the Arduino and have an Arduino control a motor that makes the top of the head spin around and look up and down and things like that. He's got his little eyes that can look around. So learning how to design those components that I can either print or hand fabricate and have things move smoothly and be controlled by the Arduino. So getting into some actual more true robotics than just stuff that's hacked together like this is one of the next things. Also, airbrushing has been on my list for a while. Yeah, Jennifer's talking about her next upgrade on the wing. So she started with the brown wings, which were a wireframe that didn't move. You could bend the wire and open them and close them just by shoving them with your arms and with a little bit of brute strength. So she upgraded from those to these black wings that open and close just left and right. But the next thing on her chopping block is wings that not only open and close left and right, but also move forward and back to give a wing flapping motion. So that's yet another huge design hurdle of how to make those sturdy and wearable and not 100 pounds. The wing set that she has is about 35 pounds. So she spent all spring and summer of last year lifting weights just to be able to wear Maleficent to DragonCon. So we got to make sure that the next set of wings are wearable, just like these. So that's the next thing on her list is even more articulation in the wings. Oh yeah, and also the Baby Yoda to accompany IG11 will have some animatronics and puppetry inside there to have eyes that look around and some hands that move and grab onto things and maybe use the force. Other questions? Anything else to? Great. Yeah, that sounds good. Other things that I can show off here. I said I really like to use the 5-volt USB batteries that are super ubiquitous. But another fun thing is 9-volt batteries that are nice and small and still give enough voltage to run several lights. So this headpiece for Jennifer, she's got a couple of them here. One that's for the aquarium party at DragonCon a couple years ago. She made this anglerfish headpiece that has the lighted bait up here, but it also has some UV lights that are here inside the headpiece. So when she wears this, it shines UV down onto her face, and she has UV reactive contacts that make her eyes glow in UV. And this helmet here, that's the same thing. That's got 2 9-volt batteries inside here that run 2 different circuits. One that makes the crystals on the top light up, again with the blue flicker chip LEDs that we saw a little while ago, and the other switch. Oh yeah, there we go with the that's this headset or this headpiece that I'm showing off, making her UV contacts light up. So it doesn't have to be this 5-volt battery. There are lots of other battery types that you can use. You can use your box of AA's in a little case, or you can use a 9-volt. You just have to do slightly different math to figure out which resistors will go well with your selection of LEDs and battery.
Do you have any specific sources that you would recommend that people look at to gain information? I mean, obviously, not everybody has got a recording of this and can replay stuff. So they need something that they can say, oh yeah, I'd like to follow this on YouTube. I mean, you can get a lot of stuff directly off of YouTube if you have a specific question, but there must be sources that you have used that might be useful.
Yeah, the rest of the maker community is really the best source that I have. And for a lot of this stuff, my primary inspirations were Punish Props and Kamui Cosplay. We follow them all the time. I also love the Craftsman Steady Crafting. SKS Props is great. If you like foam builds instead of the PVC, then Punish Props does that as well. And also Evil Ted, who is really spectacular with his foam builds. But even the people that aren't big famous names have cool things that they're working on all the time. And a lot of times, if you join maker groups like Kamui has a Facebook group that's very useful, and Punish Props has a Facebook group that they don't moderate themselves, but the other makers all kind of collaborate. So if you go in there and say, hey, here's a concept that I want to pursue, or here's a very specific problem that I can't solve, toss it out there to the rest of the maker community. And we all like to, Sheprop is another great maker community. There are tons of maker communities out there. So I can't necessarily recommend one certain source, but just look to your other makers. We all love to help each other.
Yeah, one of the things I saw in a lot of the cosplay groups, though, was that, a lot of those Facebook cosplay groups were more about people just saying, oh, look at this is something that I built.
Right.
Look at my costume, as opposed to, hey, let me tell you how to do this.
Right. And the Kamui Cosplay Facebook group actually goes the opposite direction of that, and they're very well moderated so that they have a specific one thread on Sunday that show off Sunday. So if you just want to show off your cool stuff, you post it in that thread, so you're not clogging up the whole group with just look at this cool thing.
Right.
And then work in progress Wednesday, where they have a particular thread on Wednesday that you show off your show off of your works in progress. But the rest of the group is just collaborative problem solving and question asking. But I agree that the other communities sometimes punish props, and some of the other ones are a lot of just show off, here's the cool thing that I made.
And for those people who missed it, the name of that group?
Yes, it's Jennifer, will you pop up a lower third with Kamui Cosplay? Kamui, and she's based in Austria or Germany, I think, which just shows that this is a worldwide thing that everybody's collaborating with. And she has a ton of great books. If you don't learn well from videos, if you like to have a printed book in your hand, she has just a great assortment of books. So Jennifer's popped up a lower third there with Kamui Cosplay.
He did. It's good.
So that's and if you Google search or Facebook search, you'll find the groups as well as her official page.
I'm going to say thank you for taking part, and for all the tips that you've given us today. Given a lot of things to think about, I think, and hopefully we will get our bunny ears soon.
Yeah, I hope so. So at Dragon Con, one of the fun, ridiculous things at Dragon Con is the bunny hutch party, similar to the holiday Matsuri, where everybody makes a holiday version of their thing. At Dragon Con, everybody makes a Playboy bunny version of whatever it is that they're into. So there's Assaultron wearing a Playboy bunny suit.
Do you do in a year, or is Dragon Con your favorite?
Dragon Con is by far our favorite, but we're lucky to, in Florida, have a lot of cons in Central Florida. Tampa, there's a bunch of them. There's Tampa Comic Con and MetroCon, which is more anime and Japanese video games inspired. There's MegaCon. There's Holiday Matsuri. There's just dozens of cons right here in the Central Florida area. And if you go north a little bit, you've got cons up in Lake City area. If you go south down to Miami, there's some great cons down there. Florida SuperCon, I guess. So lots of local ones, but Dragon Con is by far our favorite.
As a guest, I must say that Dragon Con was probably my least favorite.
Oh, really? That's interesting.
Because of the fact that being in 6 different hotels, when doing a panel, getting from the autograph hall to where you've got to go through 80,000 people, and then getting in on time, doing a panel and come back again it's a 3-hour event, just a 1-hour panel. And
yeah, I absolutely agree.
So when they give you 2 in a day, that means you've lost 6 hours at your table, and it makes it really very challenging, and getting doors that are supposed to be back doors, so you've got a quick entry that turn out to be locked, and stuff like that.
Yeah, I can absolutely see that. Especially if you're in a big costume like Jennifer with her wings, you have to plan, like you said, an hour and a half or 2 hours or 3 hours to go anywhere. So you got to have a handler there with you to shove your way through the crowd, or somebody who knows where they're going and can maybe take you through the secret passages and hope the door's not locked when you get there. So yeah, I totally feel that.
Anyway, thank you, both of you, Jennifer, for sitting there pressing buttons quietly in the background, and of course, Nathan, for not running out of voice or patience. I'm happy to do this.
Thank you.
Hopefully, we'll see you again sometime. We'll talk about next great creation.
Great. Thanks, Nick.
Thank you.
And there's Jennifer. Bye.
So, you know, a really big thank you to Nathan and Jennifer for doing that, because they do such a great job of breaking down how they did these things rather than just holding something up and saying, aren't I smart? Just look at what I did. And I think that that's also really great about them, is that they encourage people to get started and to have a go at something instead of you know, the opposite. It's so easy these days to take on the negativity of society or the people around you. Go, yeah, but that's a lot of trouble. Or, yeah, but what do you know about it? Well, you know, what you know about it is what you researched. And so you know, get off your butt and go make something great, which is what Nathan and Jennifer have been doing. I'm gonna put this up again for them. Be sure, if you liked what they were doing, please connect with them on No Sleep Till Cosplay on Facebook, or through their website, which is nosleeptillcosplay.com. So thanks for watching. If you enjoyed the panel, then please do, you know, consider subscribing to our Patreon page. The museum is in crisis. We have to try and sell stuff online every month in order to pay the bills, and we have our Patreon supporters who are helping us pay the rent. And a few other things. You know, people can subscribe for no more than $5 a month, or they can go a little more if they want us to keep on continuing with these broadcasts. And these broadcasts you can watch anytime over the next few weeks on replay. So if you missed it, or if your friends missed it, you know, tell them to come watch it a bit later on. Thank you for watching. This is Nick Maley at the Yoda Guy Movie Exhibit.